So good night. Today we'll be conducting a laboratory experiment, Western blot, testing protein expression level, which this is a continuation of the laboratory we had conducted before. So these are the equipments or materials that we'll be using: reagents, micropipetting equipment, electrophoresis equipment, as well as other equipments. Now we move on into the prediction part of the lab. What do you want? What do the positive and negative control change? As you can see, I already have answered this. And then for the predict bands, in this gel you will predict the band pattern that can be expected if the CRISPR-Cas distributed CCR5 successfully and Western blotting CCRP edited macrophages and control cells has worked. So I believe it is 4 gene edited macrophage, edit 4 and gene edited cell. Now we move on to the protocol, which is the lab experiment. And we can start the laboratory, which first says pour TBST buffer into the empty transfer buffer box. So once that is done, we remove the cathode lid of the Western blot apparatus to transfer release. Okay. So now what we do is we soak a piece of filter paper in the TBST buffer before we place it into the Western blot transfer. We soak a second piece as well as a third piece. Now we soak the nitrocellulose membrane in a TBST buffer, which is this here. We pick up the protein gel you ran in the previous experiment, which is this one, and we soak the gel in a TBST buffer and we place it on top of the nitrocellulose. Now what we need to do is carefully roll this over in order to get rid of any air bubbles. So once that is done, we click down here and we move on. Which now it says soak another 3 pieces of filter paper in a TBST buffer and place them on top of the gel in the transfer apparatus. Okay, another 3. 1, 2, 3. Move on to the second, which is transfer the protein. We put on the cathode lid of the transfer blot apparatus. We select the red, these here anodes, and we connect them to their respective places. Once that is done, we turn on the power supply, we set the voltage to 150 and we run it for 60 minutes. Turn it on, voltage to 150. And we set the timer to 60 minutes. Then after we place it to 60 minutes, we turn it on and we let it run, and then after we turn off the switch and we could proceed. So once that is done, we turn it off and we just put these back. Where do these belong? And we disassemble this and we just keep the nitrocellulose and we get rid of these other because they will serve no more purpose in this lab experiment. So once that is done, we move on to the third part, which is block the membrane. First, we place the nitrocellulose membrane in the Western blot box. What should you see on the membrane when you transfer it? Of course, this is the latter. Correct. We pick up the milk buffer solution and pour it into the nitrocellulose membrane. Milk buffer solution. Oh, we need to open it first. To make 5% solution, how many grams of milk powder would you need to dissolve 100 ml? Of course, that would be 5 grams per 100 millimeters. Correct. Now we place the Western blot and the machine on this lab shaker for 60 minutes, which is an hour. Then after this is done, we need to pour out the milk from the Western blot machine and we could proceed with the experiment. So as I said, we check this and we pour in the liquid waste jar and we place this on top, and we could proceed to the fourth part. Now pop-up question: now that you have blocked your nitrocellulose membrane with milk solution, you need to compute the membrane with primary antibody. How much primary antibody do you need to add to 10 ml of solution to get to a 1 to 1000? That would be 10 ml, 10 microliters. Correct. Now we use a P20 micropipette and we set this to 10 microliters. Once that is set, we get tips and we place it into the primary antibody box and we drop solution. Once that is done, we dispense this into the milk tube containing 5% milk. So once that is done, we place this and we check the tip. So I need to reset step. We draw up 10 microliters of the solution from the primary antibody. Now we dispense the primary antibody into the tube containing 10 ml of the 5% milk 1 solution. So we dispense it here. Now we eject the tip and we change this from 10 microliters to 5. We save the volume and we attach a new tip. So once that is done, now we immerse the tip solution, drop control antibody. So now we have drawn up 5 microliter. Now we dispense it into the loading control antibody into the milk 1 solution, which is this one here. Now once we have done this, we eject the tip as usual and we pour the milk 1 solution into the Western blot. So once that is done, we place the Western blot into the lab shaker for 60 minutes. Then thereafter we dispense of this liquid and we continue with the lab. Okay, so the timer is set and we could start the shaking. So now that this is done, we could eject it from here and we could do the liquid waste jar and we put back the Western blot. Now move on to the fifth part, which is wash the membrane. Now it says pour TBST buffer into the nitrocellulose membrane in the Western blot. Once that is done, we close this and we place the Western blot into the shaker for 5 minutes. Okay, now we shake it. And as it says here, usually you would repeat this TBST wash 3 times. Now we checked it and we get rid of the liquid. Move on to the sixth part. Okay. Which of the following do you think is a good secondary antibody that will bind specifically to primary antibody? So I will go with the goat anti-mouse antibody. Correct. So now what we do is open the secondary antibody tube. Okay, after incubation with the primary antibody membrane, the membrane is incubated with the secondary antibody. The secondary antibody is fluorescently labeled and binds to the primary antibody. How many microliters of the secondary solution, secondary antibody, should be added to 10 ml milk solution to create a 1 to a 10,000 dilution? That would be correct. That would be 1 microliter. So now we could continue. Now we use a P2 microliter and we set this to a 1 microliter. Save the volume so it is set. Now we pick a tip and we draw 1 microliter of the secondary antibody. So once that is done, we dispense the secondary antibody into the milk 2 solution. We check the tip. Now we pour the solution into the nitrocellulose membrane, which is here in the Western blot box. Once that is done, we close this and we put it in the shaker for 60 minutes. This just takes a little second to complete. So we can start with the shaking. And once the shaking is done, we do the usual. We eject it from the air and we get rid of the liquid and we place it into the liquid waste container, and we could move to the seventh part, which is to wash the membrane. Now here we pour the TBST buffer into the nitrocellulose membrane. Alright. Place in the shaker for 5 minutes. Oh, 5 minutes. Once we start and we do the usual, eject and we dispense the liquid. So once that is done, we could move into the last part, which is image the membrane. Now for what we do here, we take the nitrocellulose and we eject it and we place it into the Western blot imager upside down. No. So once that is done, we could start imaging. Now once the imaging is done, we have finished the lab. Now we move on into the results. After visualizing the protein bands on the nitrocellulose membrane with an imager, you can determine whether the Western blot procedure worked and your protein of interest was detected. So this was the predicted result, and this is the actual result, which I was wrong. And this is the ideal result. So your result shows a faint band of CCR5 in every 7 lane that is missing in the ideal result. How could I explain this? Okay, it was wrong. I'll go with B. No, I was wrong. Okay, so I got these wrong. And it says you need to select one species person to continue with the experiment. Predict which cell line the 4 will display a higher rate of HIV resistance. I did 4 because CCR5 is successfully deleted. Now we move on to the next section, which is the reflection. Western blot is a technique used to detect specific proteins in a sample. Question 2. Prior to Western blot, proteins in the sample were separated using the following technique: SDS, polycaramide, and gel electrophoresis. In which order should the following steps involved in a Western blot test be preferred? 1. Visualize protein fluorescence. 2. Transfer protein cells from into a membrane. 3. Incubate the membrane. So I believe it is C. We need to transfer protein, then we need to incubate the membrane, and then we could visualize the protein fluorescence. Why does the nitrous element have to be incubated with a 5% milk solution? To block the membrane before antibody incubation. Which steps create the specificity towards the protein of protein interest? Incubation with primary antibody. Now feedback questions. Well, I feel fairly confident that I could do this in real life. So that was the end of this laboratory.